Okay, so today we're going to look about z-scores and stuff like that. So if you go to Canvas, I want you to there's a PDF that's in the thing. It says standard normal cumulative probability table. It's z-scores, right? They're negative and they are positive, and they are the area underneath the curve. Okay, so I want you to make sure you have that, print that out, or reference that. Now, before we get really into too much, Z scores. Um, why do we have Z scores? Well, yesterday you filled out the one standard deviation, two standard deviation, three standard deviation, above the mean and below the mean, right? And everything, and that was great. But what if a value that we are needing is not on a 1, 2, or 3 above, or 1, 2, or 3 below the uh, mean? What if our data point is not on a perfect standard deviation unit away from the mean? Well, that's why the Z score came about. Okay, it allows us to be able to find things in between. Now, on this particular problem right here, problem number one, it says, let me check on something real quick. All right. Yep. Problem number one right here says find a standard normal distribution. Find the probability that a z is less than 2.36. All right. So what you do is you go to your z table and you go to the positive 2.3. So it'll give you the tenths. Oh, excuse me, tenths on the left hand side. Then up at the very, 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 very top, you'll see the hundreds place, like 0, 100, 200, 300, 400, 500, 6, 7, 8, 900s, right? So on this one, it said 2.36. So this would be 2.36. So it would be 0.9909, right? That's the probability given the situation that we're looking at. Rounded to 4 decimal places, it's already a 4, right? So, any questions on this one? This was problem number one. Straight reading from a Z table. Yep. So you go down to meet where because you'll be giving it to 2 decimal places, right? Or you read it to 2 decimal places. So, and then you'll find what its area, and we call the area the probability, right? Underneath the curve. So, on this, why is it what? Well, instead of having a list that had all this right here, 2.40, 2.401, 2.402, 2.403, blah, 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 and it be major pages. What they've done is they've listed it to the tenths, and here's the hundreds that follows that tenth, right? So you find the tenths place, the number up to the tenths place, and then if it's positive or negative, and then you go over and find the hundreds on that, and that's how you do that. And that's what I showed here. I just kind of wrote it above it. You know, you went to the positive 2.13, and I was looking at, or that 2.13, 2.3, and then you have to go to the 6 because that right there would represent this 2.36. So if I were to go to my Z table, I would go 2.3, move this over, 2.3 over to the 6, and I get 0.9909, right? Here's the 6. It's where they meet. And that's what it showed on one of the videos. It showed a really good, really good example. Now, so that's the first one, if it's less. Now, what you have to understand is the less means that it's from that point to the left, right, of the normal distribution, right? So what we're using is a left left side shaded Z table, right? See that? Whether it's above the mean or below the mean. If it's above the mean, it's a positive. If it's if it's below the mean, then it is negative. Okay, that's how you know where you're at with respect to the mean. Now, this one said probability of z-score greater than 1.9. Okay. Well, you've got two things that you can look at this, and I've done this looking at the table. And if you look at it, my table, my bell-shaped curve, 1.9 means it's a positive, right? It's above the mean. So, I just kind of drew it and I said, okay, I'm looking at setting above 1.9. So that's the blue here. Do you see the blue? But when we read the table, this value right here is everything to the left of that, right? 0.9713. If I go to 1.9, 0.973, that is to the left of it, right? That's everything this way from that 1 point positive 1.9. So that's why I went 1 minus that and got 0.0287. Okay. Now there is a little trick, and I say it's a little trick, but there is a little understanding that if you notice that I was at positive 1.9 here, but if I looked at the negative 1.9, right, and I looked at its Z table, look what it gave me, 0.0287, right? So you got to know whether you're looking, if you're looking at values greater than, then it's easier just to take the negative of it because that's really what it's going to be, or find it and then subtract it from 1. You get the same thing. These are the same values. Do you see that? Okay. So you just got to, this is a key right here, greater than. That's what I got to consider, right? Because it's to the right, but all of my values are to the left, considering everything to the left, right? So that's why. All right, so that was number 2. This is number 3. And what number 3 is it's saying find the probability between two z-scores, right? And so I just kind of drew it out and said negative 1.84. Negative, I knew it was below the mean. Positive, I knew it was above the mean. So what I did was I went and found what the z-score for negative 1.84 was, right? 0.0329. And since I'm trying to find between it, you see how I have drawn this. This 0.9964, the 2.69, is looking that away, right? Okay. And the negative 1.84 is looking that way. So if I want to know what it is between them, all I have to do is take that's right, and that gives me this. Yep, that's the probability between those two z-scores. Yep, that's the area under the curve. So those are your three setups, right? Okay. Now, I want to look. I marked out number 4, but I want you to kind of look at number 4 because I did it, and based off the table, I did it correctly. But if you were to calculate it using your calculator, using a normal CDF instead of a normal PDF, probability distribution, as opposed to a CDF, see how this range is 0.544? So I just read that, negative 0.54, right? Could you take it and, well, I guess you could. Let's see. I bet you they did. I really didn't consider this, but I may go back. But let me see. Negative 0.54. That would be this. And if I were to go, let's just for grins and giggles, right? I took these off because, you know, negative 0.55 would be 0.2912. So I'm just curious. Let's see. Minus, yeah, because that'd be the bigger, 0.2912 divided by 10. I'm just wondering if they are doing this. Yeah, I took these off, so you don't really have to worry about this, but I never did consider this. 10, it's 10 spots, right? So that'd be 0.00034. And I've got how many of them? I've got, well, let's just say, let's see if it works. Let's take that. That's 10. That's each one, right? That's equal to 0.01 between these, right? So if I do that times 10, yep, and then add it to 0.2912. Yeah, it works. All right, so what they've done is they have divided this, and I'm pretty sure it'll work, and broke it up. So I've got to have how many of these? I got to have four of these, right? Does that make sense? So 0.01, no, sorry, not 0.01, 0.0034 times 4, right? So I would say that negative 0.544 was at this. It'd be, let's see, it'd be this one, 0.2912 plus 0.0012. 4, which would give me plus 0.2912. Yep. There you go. Yeah, pretty sure that's it. So I'm gonna turn 4 back on, probably 5 back on, and 6, and that's how they're doing it. I just, when I went to do this, I just didn't consider it, breaking it up into tenths, or not tenths, not hundreds, but thousandths, right? Um, so that'd be that. Yeah, it'd be a thousandths there. So are you with me still, or did I lose you? Okay, so what I did was 0.54, negative 0.544 is between these two, right? Okay. So what I did was biggest one minus littlest one, right? Divided by 10. So each one of them, each 10 hundred thousandths, each thousandths was 0.0034. And I needed how many of them? So I took this times 4 and got, guess what? 0.014. Added it to the 0.2912, and I get 0.2916, or not 216, sorry. So yeah, I'm gonna put those back on. There you go. Okay, but do you see how I've got it drawn here? Okay, negative 0.544 is between 0 and -1, right? Well, our Z table is only to the thousandths, right? No hundreds. So we could break it into the thousandths if we wanted to find what's in between. So that should work. There you go, 0.296. So that was number 4, I think. So 4, 5, and 6 are like that. So I'll go back and I'll add those. Yeah, I add those, just gonna clear out some people, and I'm not sure how many people has done this yet, but I have to look at it. Or I might go back and add them in addition to it. So I'll go back and probably grab them. But that's yeah, that's what you can do, right? So, all right, assuming that uh, the readings at freezing on a batch of thermometers are normally distributed to a mean of 0 degrees C and the standard deviation of 1 degree C. What's the probability of reading less than negative 0.544 C? So it would be 29.26% if you looked at it as a percent, right? So probability. All right, so there's that. So I'll go back and add 4, 5, and 6 back in. Now, let me jump to number 9, okay? Because number 9 has one that just says, here's a normal distribution that has a mean of 121, a standard deviation 4. Find the z-score, only the z-score, right, for the data value of 119. So the z-score is x minus the mean over the standard deviation. So 119 minus 121 over 4 gave us negative 0.5. So it had a z-score negative 0.5, right? That is, if we had to round it 2 decimal places. So it didn't say go find the value of the z-score. It just said go find the z-score. Okay. All right, so that's number 9. The next one that I've done was number 11. This one says find the probability that z is less than 2.23. Well, you just read it right off the table, right? If I were to go to 2.23, 2.23, right? 0, 1, 2, 3, 9897, right? 9871, right? Right there, 9871.9871. There you go. Do you see where I went? 2.2, here's 0, 1, 2, and what? There's the 3, right? So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? So there you go. So that's number 11. 12. 12 said find the probability, go to 4, given a z-scored, right? Find the area under shaded. That's a 1, right? So our z's, our area underneath is giving us everything below. So if you looked at 1 as a positive, that would be, one of it as a positive would be 0.8413. So because it's the area below it, right, z of 1, it'd be 1 minus 0.8413, which is, guess what? But if I were to look at the z of a negative 1, because that would be like here, right? And see, because it has a bell-shaped curve, it's symmetrical. Everything over here is equal to everything over there. So if I go look at negative 1, guess what I get? There you go. Okay, so that's what you can do. If it's greater than, because you're looking at it, all your values are to the left of that. So greater than means you're looking to the right of it. You're looking at this area, so you have to do 1 minus, right, that value. But if you looked at a negative 1, it would give you, because you're at negative 1, you are looking at everything to the left because it is symmetrical, right? So that's the number 12, right? That's the number 12. And that's it. I think out of that, you should be okay to be able to know how to do the rest of them, and everything, at least up to, with your questions for tomorrow. We'll have an online help session tomorrow, and you can bring in your questions of ones that you haven't got yet. But again, I'm going to put 4, 5, and 6 in. My brain just didn't click when I was doing that, but it did when I did it this way. I don't know why it didn't, but it did now. So there, I'll put them back in. But that's it. Yesterday's homework plus this homework ends this week. We'll have a quiz, and then we'll start the unit review for Unit 7, and that's it. 8th.